We want to find the area of the outer loop then of r equals 2 plus 4 cos theta. So we'll do a little sketch here just to be just to see what the bounds are going to be and what we need to evaluate. 2 plus 4 cos theta, when cos is 0, we've got 1. So that would be 6, won't it? So we'll get 6 there. When it's equal to pi over 2, that's 0, so it becomes 2. So it goes round from 6 to 2. Now the question is, when does it come round to 0? When is this 0? Well, it's equal to 0 when cos theta is minus a half. So if we draw that, cos theta is minus a half is this line here, it's got to be, because that's when this curve comes round to 0 here, and it's symmetrical. So, and then of course it goes round, and it's going to go like that, isn't it? So from 0 to this angle, but we want the outer loop. So we're interested in this area from here round to here, aren't we, where it stops here. This is theta equals 0. And then we can simply times it by 2. Well, we've got the outer loop then, haven't we, for the whole area. So, okay then. So when does cos theta equal minus a half? Well, if cos 60 is a half, isn't it? So if we put 60 in here, then we know this is second quadrant. So theta is 120, isn't it? Because cos of 120 is the same as cos 60 with the minus. Cos 60 is a half, and we get the minus a half. So that's 2 pi over 3 in radians. So that's what we need to do then, from 0 round to 2 pi over 3 and times it by 2. So here then, so here, the area is equal to a half, 2 lots of, so I'm going to put the 2 up there, 0 to 2 pi over 3, isn't it? That's 120. Of 2 plus 4 cos theta d theta, and this is r squared. There we go. So that's equal to then, these 2's cancel, we're just left with the integral between 0 and 2 pi over 3 of this squared, which is 4, first term. We're going to get 8, 2 lots of 8 is 16, so it's 16 cosine theta, plus, and then we'll also have a 16 cos squared theta d theta. So that's equal to then, let's just carry on with the integral, 0 to 2 pi over 3, 4 plus 16 cosine theta plus, now 2 cos squared, so I've got an 8, and we can replace the 2 cos squared by cosine 2 theta plus 1 d theta. There we go. So let's work out this now then, shall we? So we've got a 4 plus an 8 here, which is 12. So when we integrate 12, we get 12 theta. This integrates to 16 sine theta, doesn't it? And this cos with 8 integrates to 4 sine 2 theta. Just check that. When you differentiate this, you get cos 2 theta multiplied by the 2, because it's a function, which will give you 8. The 8 that comes from the second term expansion here has already been added to the 4 to get 12 and integrated to get 12 theta. There's no value outside the integral, is there? So we simply need to work that out between 0 and 2 pi over 3. Now, what do we get then? Let's have a look at this. It's 12 times 2 pi over 3. So this is the top value, plus 16 sine 2 pi over 3, plus 4 sine of 2 lots of 2 pi is 4 pi over 3. Equals, take away 0, because when you put 0 in for all these, so I better put that there, hadn't I? Minus, so we're absolutely clear, minus the second term, 0. Top value, put them all in, take away bottom value. So what do we get? We get 24 over 3. 24 over 3 is 8. So we get 8 pi here. Now sine of 120, is the same. That's sine 120 in degrees, which is the same as sine 60 because it's in the second quadrant. But let's type it in the calculator for these two latter terms, shall we? So we've got 16 radians mode 4. So we've got 16 sine of 2 pi over 3, 2 times pi divided by 3 plus 4 times sine, and it was 4 pi over 3, wasn't it? 4 times, we'll check it in a moment, pi divided by 3, close that bracket, equals 6 root 3. Yeah, 4 sine 4 pi over 3. So let's just check we've entered it correctly. I'm just going to run through it very, very quickly. 16 sine 2 pi over 3 plus 4 sine 4 pi over 3 equals 6 root 3. So it's that many units squared, isn't it?